Hello and welcome back to Calculus 3. Finally, one of my favorite sections, Lagrange multipliers. Now, you can tell that I taught Calc 3 in a classroom which has the spray bottle that has a line on it, because that's what I do when I teach. I usually draw this line on any one of these guys that are available to contrast what the Lagrange multipliers calculate, because again we are looking for min and max. But now, what kind of min or max are we looking for? So if you remember your min and max problems from Calculus 1, the word problems, you had an objective equation, and then you had the constraint equation. Constraint equation was the one that had the relationship between, let's say, x and a y, and the objective equation was the one that you minimized or maximized. So let me just quickly remind you of the Calc 1 stuff again. So in Calculus 1, you would say find max product such that sum is, find x and y that will lead to max product, right? Find x and y, two numbers, such that sum is, 32, whatever. So you would say x plus y is equal to 32, and that would be your constraint function. And then you would have x times y equals a max is your objective function. And the way you solve these problems, you took this equation, solved it for either x or y, and then plug in. We're going to do something very similar now. Plug in, and you will get your x times 32 minus x equals to a max, which is 32x minus x squared equals to a max. And then you will differentiate that in respect to x. And when you differentiate, remember, max is the maximum value, which is a number. So you would get 32 minus 2x equals a 0, from where x is equal to 16. So 16 plus 16 is 32, and 16 times 16, right, 256 is the largest value that you can get. So it was a game of two equations, and you were able to find a value for x and a value for y, which will make a maximum area, maximum volume, minimum profit, maximum profit, minimum cost, and so on. Now, what's happening in Calculus 3? We already covered a section that does min and max on the shape. But now, I'm going to have a shape that has a constraint. That could be intersection with another shape, or it could be a line drawn on the shape along which you are calculating. So if I am to put this spray bottle like this, your min-max procedure for 12.8 are going to detect this point here as a minimum point for the bottle once you run all the equations. Lagrange multiplier is going to find the minimum point on this shape, right, the constraint, for this line as this point here. You see the difference? So the Lagrange multiplier is the unity of the shape with some other constraint, where the 12.8 was just the shape. So 12.8 computes this point as a minimum. Lagrange will compute that point right there because that is the where you have the minimum for the shape and the line at the same time. Bueno? So that's the difference between the two. Now, which one makes you money? Both of them, but Lagrange makes more. Okay? So Lagrange is where your engineering is, where your business is. And these things there are. And obviously, now that you know this, you can finally start your project so I can unlock the secret and you can enjoy Calc3 project. No, but I can post it now because this is the last piece of the puzzle you needed. So now, what is happening for Lagrange? We are going to have the procedure, which is, again, you look at the geometry, you come up with equations, you put them together, and you solve it, right? So the procedure is, let's do it red over here. Number one, find objective and constraint equations. So you have to find these equations first. Number two, del F equals lambda del G. Now, objective equation, f of x, constraint equation of, x, y. But now you can have mx, y, z as well, depending on what you have. So then you will equal the two, and that step number two is going to create three equations for you. Well, two equations plus the constraint. Solve the system to get points. And then finally, 4, test the points. Now, obviously, you're looking for a max, you're looking for a min. The highest of all maxes is the max, and highest of all z's is the max, lowest of all mins is the. So, someone's eraser?
Oh, that's fine. Thank you.
Catch.
Don't worry.
I'm terrible at throwing things, as you can see. Instead of throwing it forward.
What was number 4?
What happened?
What was number 4?
Test the points by which max, which min. All right. There is obviously 3 variables, so 2 variable or 3 variable problem. So let's start with just a problem that is going to outline the procedure. So we have f of x, y is x plus 2y, subject to x squared plus y squared equals to 4. So again, no meaning to this problem, it's just grind to learn the procedure, mechanics. So your g, which is the constraint, is going to be x squared plus y squared minus 4 equal to 0. What's del F? Gradient. Anyone remembers gradients? It's going to be a test in 2 days. Perfect. So, vector of partial derivatives. So what's the partial derivative in respect to x? Good. What's the partial derivative in respect to y? Nice. Now what's del g? Very good. Yeah, it was way too much time. Now, what we do next is we equal these using the Lagrange parameter lambda. Now, we don't need this parameter lambda as our answer, so we try to eliminate that first. So look what I have. I have 1 is equal to lambda times 2x. That's the first equation. Then I have 2 is equal to lambda times 2y. And I also have x squared plus y squared equals to 4. This is your system. Observe that you have 3 equations and 3 unknowns, and we don't care about lambda. So try to eliminate lambda if you can. If you can't, well, in some problems, a very narrow number, very small number of problems will be forcing you to compute lambda first and then everything else. But majority of them you will be able to eliminate lambda and just go on. So we need to solve this system. Usually this is a nasty nonlinear system. This is easy here, but you know, some crazier cases are coming up. What I'm going to do is I'm going to solve for lambda on the first one and plug that in the second equation. So lambda is equal to 1 over 2x. And I'm going to plug in the second one. So I get 2 is equal to 1 over 2x times 2y. The 2's can drop. And I get the equation that 2x is equal to a y. So by combining first 2 equations together, I got a nice relationship between x and a y, which I further plug in into the third equation. And I have that x squared plus, instead of y, I'm writing 2x. And I'm squaring that, equals to 4. So that's 5x squared is equal to 4. X squared is equal to 4/5. So x is equal to plus minus 2 root 5 over 5 when you solve this. Now I have that y is equal to 2x, so y is equal to plus minus 4 root 5 over 5. I have 4 points of interest. I have 2 root 5 over 5 and 4 root 5 over 5. I have all combinations of these, right? 2 root 5 over 5 and then negative 4 root 5 over 5. And then I have negative 2 root 5 over 5 and positive 4 root 5 over 5. And finally, negative 2 root 5 over 5 and negative 4 root 5 over 5. Max, max, min, min. Looking. Oh, whoa, 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 hold on. Ah, you didn't see this? You didn't see this? No one saw anything? These are your x and x and y values. So now you plug them in to get your z values, which will tell you which ones are mins and which ones are max, all right? So now we know that our equation, the f of x equation, right, the objective, so fxy was x plus 2y, and this is where we plug in one at a time to figure out what we have. So f of 2 root 5 over 5 comma 4 root 5 over 5 is 2 root 5 over 5 plus 8 root 5 over 5, which is 2 root 5 altogether. So now I have a point 2 root 5 over 5 comma 4 root 5 over 5 comma 2 root 5. That's my z value. And then repeat. Next point is 2 root 5 over 5 and then negative 4 root 5 over 5, which is 2 root 5 over, I'm already tired, minus 8 root 5 over 5 equals to, that's a negative 6 root 5 over 5. So 2 root 5 over 5, negative root 4 root 5 over 5, and negative 6 root 5 over 5. Nice. Did I mention it's going to be a little bit tedious today? No? It's going to be a little bit tedious today. I just stopped talking and I'm just writing stuff. I got bored of saying root 5. I'm still saying it in my head. That's annoying. Looking at the y values, it should be clear which one is min, which one is a max, because the highest of all z values, the lowest of all z values, reveals that right away. Bueno. This is it. If you know how to set the gradients together, x coordinate, don't forget the lambda, procedure-wise, you're done. The question is, do you know how to solve nonlinear systems, right? That's a pre-calc 1 in this school. The chili pepper book, section 7.3, I believe. So nonlinear systems could be very tricky to solve, and you could just, you just practice and push, and eventually you break through. It's a limited, number of finite number of tricks that we use to solve them. You want to try one of these on your own? Of course. What else? Before we jump into word problems and 4D stuff, let's just you on the one with E? No. How about, well, okay, you pick something from 6 to 14. I'm just waiting for someone to say 11 because that's the one with E. 11. No, I heard 6 before. 6 was first, but then it doesn't really matter. They're all awesome. All right, you know what to do. Had enough, huh?
Don't I always?
Huh?
Don't I always?
I'll see. I did a little bit of work. Now try to solve the system. You can check. What's
Or your string went off blank for a second, then it came back.
So from the second equation, if we eliminate 2 and y, which prevents us from y being a 0, let me just run that logic real quick. You are not supposed to divide both sides by a variable, because that variable could be 0. And if you divide both sides, then that means that you are not allowing for it to be 0, and that could be an issue, obviously, because you are losing a solution. In this case, however, I seen that if I allow y to be 0, then on the top equation, y equal to 0 would mean that x is equal to 0, and then both y and x would be 0, which doesn't work in a third equation because 0 plus 0 cannot be 1. You see that? So let me run one more time. If I allow for y to be 0, then because y is 0, x must be 0, because that's a constant times 0, right? And then I would have 0, 0, but 0 plus 0 cannot be 1. So y is not a 0, and that's why I'm allowed to divide both sides by y. So using that manipulation, right, that logic, solving the system, I found quickly that lambda is equal to x, which I plug in up there, and I get that y squared is equal to 2x squared. From where y is equal to plus minus root 2x. Actually, no. Scrap that. I don't want that. I don't want this. You know why? Because the bottom equation has squares. It's nice. So now plug in. X squared plus 2x squared is equal to 1. From where 3x squared is equal to 1. From where x is equal to plus x squared is equal to 1/3. So root 3 over 3. So I found x's, right? And now I plug that up there to get y's. So I know x squared is 1/3. So y squared is equal to 2 times 1/3 is 2/3. From where y is equal to plus minus 2 root 3 over 3 when you rationalize. The rest is a familiar grind. Write all 4 points, compute their z values, largest value, smallest value, and so on. So 4 points of interest are root 3 over 3, 2 root 3 over 3, root 3 over 3, negative 2 root 3 over 3.
Is it 2 root? Is it to take the square root and rationalize would be root 2 times root 3, root 6 over 3?
Over here,
Yeah. Then you take the square root would be root 2 over root 3.
root 2 over root 3. It's root 6 over 3. Yeah, that's, I was just testing you. And you just passed the test, so that's very good. Awesome. There they are. Those are x's and y's plugged in the original equation, right? And find which one is. So there's more work to be done. But we are going to jump and solve one of the. We have enough time. That's what? 1 minute left. And then another 40 minutes after that. So we have time. This is all preliminary calculations before we hit word problems, where we get to model and then do this. Which problem do you want to do? 15 through 24? 22. All right. F of x, y, z is x squared plus y squared minus z, no square. And the constraint is z equals to 2x squared y squared minus 1. No, plus 1. You need 3 partial derivatives.
Five
will
projects.
lab.
Oh, five.
5 lab, 1 project that has 3 problems. Yes, totally negative. For both, not just one of them. Minus C, isn't it? Because C's on that side, you want 4 on over the other side. Because we want to be in terms of all 3.
So where do you start solving this system?
Yep,
Where?
sure do.
This one is really nice. So where do you start? Line 1, line 2, line 3, line 4? Line 3? Why? So what do you learn from line 3? No, it does. Lambda must equal 1. Line 3. In order for minus 1 to be equal to minus 1, lambda must be 1. That kills lambda. Lambda equals 1, you can just erase it everywhere. And you are immediately done with one variable. You are left with x, y, and z to worry about 3 equations now. So in this case, if you ever see equation like that pop up, that one is immediate. Lambda equals 1. That simplifies your system. You can also cancel by 2 the first 2 equations. And then we'll think about zeros and stuff. So 2x y squared. Y is 2x squared y. And z equals 2x squared y squared plus 1. So now this is the new system simplified. And now you say, is it allowed for x and y to be 0? If you put x equal to 0, that means y must be 0. But then z could be 1, right?
For both x and y equals 0.
Yeah. Are there other solutions other than 0, 0, 1? So now we found one solution already just by inspection. If x equals 0, then y must be 0, and then z is equal to 1. So we already know 0, 0, 1 is the solution.
You could have 3
Well, now that we know that we have a solution for z, we can actually cancel and look at the rest. So cancel x. And we can cancel y. So from here we learned that y squared is 1/2. From here we learned that x squared is 1/2. And now when we plug that in a third equation, we get z equals 2 times 1/2 times 1/2 plus 1. So z equals to 3/2.
How did you set those?
I canceled because I already took care of 0. So now when I cancel by x, I get this. When I cancel y, I get that. And now move 2 to the other side. I get these, and then plug those in here. Those are the halves, right? And I get 3/2. Now, how many points do I get here? I get 4 points, right? Yeah, because each one of these gets a plus minus root 2 over 2.
Right.
What about the other one?
But that's the fifth one.
Okay, there.
Yeah, we're getting. Oh, did you say 5? I heard 1, and I was like, All right, yes, 5. We get 4 from here, and the 1, 0, 0 is fifth. Good. So what are the points? So eventually this one is y equals plus minus root 2 over 2 when you rationalize, and this one is eventually x equals plus minus root 2 over 2. So 5 points. Yes.
One. Oh, never mind.
Are you ready for the word problem to enjoy?
When you say enjoy, actually,
Yeah, enjoy. You know, like when you have a breakfast that contains all of the ingredients that one should enjoy, like bacon and eggs and stuff. Yeah. Shipping regulations. Something that I would do. A shipping company requires that the sum of the length plus girth of rectangular box must not exceed 108 inches. 108 inches. Find the dimensions of the box with maximum volume that meets these conditions. So, What are they concerned with? They are concerned with this plus the length. So x, y, z, and the constraint g of x by looking g of x, y, z is clearly 2x plus 2y plus z equals 108. That's our constraint. The girth is the sum of the edges in the face, and then the length, in our case z, so plus z. So that says the shipping company requires that the sum of the length plus the girth of the rectangular box must not exceed 108 inches. Great. And they want what? They want a box with maximum volume. Volume is x, y, z equals mx, and that is your objective function. Del f, partial derivative in respect to x, y, z. Partial derivative in respect to y, x, z. Partial derivative in respect to z, x, y. Del g, partial derivative in respect to x, 2. Partial derivative in respect to y, 2. Partial derivative in respect to z, 1. Del f equal lambda del g. See, it takes 6 seconds. Set up the system. Yz equals 2 lambda. Xz equals 2 lambda. Xy equals to lambda. And then what? The 2x plus 2y plus z equals to 108. That's our system. We have what lambda is equal to, so plug in. When I plug in lambda, I get that yz is equal to 2xy, and I get that xz is equal to 2xy. What can I conclude from here? Y and x are equal. Because this is identical and this is identical, so x equals y. Very good. So that will make our bottom equation, x equals y, to have, let's say, 4x plus z equals to 108. Eliminate y, maybe from this equation. We get that xz is equal to 2x squared. Now, I hope you see that x and y cannot be 0. Why? What happened? The lengths, right? You're shipping a crate. Can you allow for a side to be 0, therefore area to be 0? No, right? So x and y are not allowed to be zeros. Anything but 0. They're not also allowed to be negative numbers. These are lengths of the packaging. So they have to have some length in inches. So x and y are not allowed to be 0. Therefore, I can cancel on the bottom by x and get that z is equal to 2x, which I plug up there. It's just a lot of plug in, plug in, plug in, plug in. So now 4x plus 2x is 6x. Which is equal to 108. 6 and 10 goes once. 6 and 48 goes 18 times. X is 18. Immediately, z is twice as much, 36. And we said x equals to y up there. Dimensions. (18 by 36 inches). This package would allow for maximum volume. 18 by 36. So one more example, and then we'll pick up next class, which is all the way tomorrow. We'll pick up in 22 hours from now. It says find the dimensions of the rectangular box with the volume of 16 feet cubed that has minimum surface area. Let's see. What's the area?
Yep. X, Y, Z.
That's the volume.
Oh, area, sorry. 2xy plus 2yz plus 2xz.
2xy plus 2xz plus 2yz. Good. And we want that area to be minimum. Now, why would you want a minimum surface area? What is that guarantee? Cost efficiency. Why and how? Excellent.
Less material.
Less material to make the box. Guys, packaging engineering at Rutgers. Hot topic now, apparently. You're having a job before you even graduate. That's what I was told. Now, that's now. So packaging engineering is a big deal currently because, 107% of goods need to be shipped from China right here. So.
I have a horrible building. It's like windows are broken out.
Hey, what are you saying?
It's a horrible building.
What?
Horrible building for that. But doesn't matter.
Package engineering building.
What about? Oh, it's about
It's like,
Multipliers.
it's like broken. I passed through.
Let's think if let me go.
So our del f is partial in x. So partial x is 2y plus 2z. Partial of y is 2x plus 2z. And partial of z is 2x plus 2y. And our del g is xy. So yz first, and then xz, and then xy. What happened? Yeah. Constraint is v, which is g. So now we have 2y plus 2z is equal to lambda yz. Then we have 2x plus 2z equals to lambda xz. And we have 2x plus 2y equals to lambda xy. And we have xyz equals to 16 or 18? 16 it is. And now we have the system. Now we need to solve this. Observe that x, y, and z cannot be zeros because we are talking about a box that needs to exist. Please use common sense every time. Now, as soon as you eliminate 0, 0, you are allowed to start dividing by variable. Now, since all these equations are symmetric, this should be just a cube, with the answer being cube root of 16, which is 2 cube root of 2 each side. But then let's say you don't know that. How do you solve it? At which point Alex will say it's a very good question. You would say it's a very good question.
Oh, that's a very good question, Professor.
Excellent question. Amazing question. So divide each equation by whatever is there with together with lambda. So first equation, I would divide by yz and try to see what I get. So lambda is equal to 2 over z plus 2 over y. Divide second equation by xz and the third equation by xy. So I'm hoping, to isolate these lambdas and see what I get. So now I have these equations, and I can equal them. So equal these two, let's say, and these two. See what I get from there. That eliminates lambda. So I have 2 over z, plus 2 over y equals to 2 over x plus 2 over z. And these guys drop, and I get x is y. When I equal the first and the last, so 2 over z plus 2 over y equals 2 over x plus 2 over y, these guys drop, and I get what? Very good. Now, if x is equal to y and x is equal to z, you want to make a point, immediately explodes. It's amazing. It's just waiting for me to get excited, to make a point, and it goes. All right, let's see. Oh no. He died long time ago. So now these die. The first one is saying that x is equal to y. The second one says that x is equal to z, which means that also is y equals to z. And now we have x equals y equals z, and we also have x, y, z equals to 16. So you can go with x cubed equals to 16. X equals y equals z equals to cube root of 16, which is 2 cube root of 2. So the dimensions are, it's a cube. And there you go. So that's it for tonight. We are going to continue tomorrow with a few more of these word problems. I encourage you to try them first so you know what to ask. And then we'll also hopefully start 13.1 if we have chance, or continue with the lab. We'll see.
Oh wait, so there's still more of this.
No, the concept-wise, no. It's just a whole bunch of problems. We only did 2 word problems out of 30. All right. See ya.
Thanks, man.
Bye-bye.
When do we